Welcome back, students. As I was telling in the previous lecture, in this particular lecture we are going to club the things together. Just to give you a small summary of whatever was happening in the last lecture is, we connected three different components to your alternating source. They are the resistance, capacitor and inductor. I connected it to the alternating source, and I have also shown you what are the variation in the voltage and the current in those particular components. Now similarly, I am going to put the components together. Okay, I am going to pair them. First I will be connecting the resistance and the inductor, next the resistance and the capacitor, then the inductor and capacitor. Like this I am going to club them together. Let us see what is going to happen. In the first case, I am going to put resistance and inductor. I am going to put the resistance and the inductor together. Listen, the resistance is like this and the inductor will be like this, and I will be connecting it to an alternating source. This has got a value of R and this has got the value of L, and the EMF is going to be E0 into sin omega t as usual. So now the individual potential drops are VR and VL respectively. VR and VL respectively. The overall potential is E0 into sin omega t. E0 into sin omega t it is. Right? Now if you see, both the components are connected in series so that the current that is running through them are going to be the same, but the potential drop on the individual components are going to change. So listen, I am going to directly deal this particular concept using the phasor diagram. So the phasor diagram for this particular thing looks like this. It will be VL in here and it will be VR in here. Reason that your inductor and your resistance, the potential drops on the inductor and resistance are 90 degrees away. Otherwise, I can also deal it with a different way. See, the current and the voltage drop on your resistance are in phase. Remember, that is the reason why I have drawn them in the same line, whereas in your inductor the voltage leads the current by pi by 2. That is the reason why I have written them in the y-axis like this. So now what is the total E in here? What is the total E in here? Where I call this to be the phase angle. Where I call this to be the phase angle. Now listen, what I am going to do is, I am going to find my E. E is nothing but the resultant of VL and VR, where E is equal to root of VL square plus VR square. VL square plus VR square, where E is equal to root of I into XL the whole square plus I into R the whole square. I into R the whole square. I am going to pull my I's out, where E is equal to I into root of XL square plus R square it is. E by I is your impedance Z. E by I is nothing but the resistance, which is nothing but the impedance Z, which is equal to root of XL square plus R square it is. It is R square it is. This is nothing but the total resistance offered by this particular circuit. This Z is nothing but the total resistance offered by this particular circuit, and it is given like this, where tan phi is equal to opposite by adjacent, which is nothing but VL by VR. It is nothing but VL by VR, which is equal to IXL by IR. I and I will go down, which is equal to XL by R it is, which is nothing but XL by R it is. Again, how will you rewrite your XL, by the way? Your XL could be rewritten as, the XL could be rewritten as omega L. Omega L by R it is, and omega could again be rewritten as 2 pi mu into L by R. So these are the different ways of writing your phase angle, and this is what will happen when you put your resistance and the inductors together. And if you see the voltage leads the current by phi. That is what the phase angle is. Voltage leads the current I by phi. Now, in the next session, in the next heading, I am going to put together my R and C. Now, let's see what is going to happen. See. Resistance and capacitor. So now I just put a resistance and a capacitor together. The value of the resistance is R and the value of the capacitor is C. So now same exact things are going to happen. The first thing, the current that is going to go through this is going to be the same, whereas the potential drops are different. So since the current going through this is same, and in the resistance the voltage and current are in phase, then the voltage drop on R and I are in the x-axis, whereas the voltage drop on C, the voltage drop on C is out of phase. Otherwise, the voltage drop on C is going to lag the current. Voltage lags the current in your capacitor. So that is the reason why I have drawn Vc down, where your E will point this way. So E is equal to root of VR square plus Vc the whole square. VR square plus Vc the whole square, where E is equal to root of IR square plus I into Xc the whole square. Where E by I equal to root of R square plus Xc the whole squared. So now what is E by I? Is the resistance Z, which is nothing but the impedance or the total resistance of this circuit, which is equal to root of R square plus 1 by omega C the whole squared. After that, in your numerical problem, if they give you the value of the frequency, try to rewrite that omega as 2 pi mu and then substitute that value here. Now again coming to the phase angle, which is nothing but given as tan phi. Here it is phi in here. So tan phi is nothing but Vc by VR. Vc is written as I into Xc by I into R, which is equal to 1 by omega c, 1 by omega c by r it is. 1 by omega c by r it is. This is called the phase angle phi. This is called the phase angle phi. And I can say that E lags current. E lags current I. This is what I learned from this particular combination where I put together the resistance and capacitor. This is the value of the impedance, and this is how your voltage and the current is going to behave. The simple and important. Next, similarly, we are going to pair the inductor and capacitor. See, what happens if you pair the inductor and the capacitor? This is L and this is C. This is inductor and capacitor. Very easy. Again, the current going through them are going to be the same and the voltage drop is going to be different. And if we see this voltage drop on the inductor, the voltage on the inductor is out of phase with the current by pi by 2. In fact, voltage leads the current in inductor. Voltage leads the current in inductor, whereas the voltage in your capacitor is going to get lagged. Whereas the voltage in the capacitor is going to get lagged from the current in your capacitor. So, this is how your phasor diagram looks. Voltage lags the current in your capacitor. Yes. So, again everything is going to be straightforward. Now, you see both are vector quantities, both are pointing away, whereas in the previous cases these two vector quantities were making 90 degree, and that is the reason why we took resultant for them. But here they are exactly on the opposite ways. So, if VL is greater than VC, then the total E is going to be VL minus VC. The total E is equal to VL minus VC, where E is equal to I into XL minus I into XC, and collecting that I outside, I is equal to XL minus XC. If I bring my I down, E by I is equal to XL minus of XC, where XL is the resistance offered by your inductor and XC is the resistance offered by the capacitor. Again, E by I is nothing but Z minus XC, XL minus XC. This is the resistance offered by this particular combination of the circuit, where the resistance is going to get subtracted. The resistance is going to get subtracted. So, this is how the things are going to really work in here. There is no phase angle for this particular combination, and for the inductor and the capacitor, the current is going to stay away. For the inductor, the current lags. For the capacitor, the current leads. So there is no angle, the phase angle between the voltage and the current for this particular combination. With this note, I would like to end up this lecture by saying that in the next particular lecture, I will be putting all these three components together and I will be doing the same exact thing what I have done here. So, I think it is better you will try it once before seeing that video. It is going to be very straightforward. In the next video, we will deal with the LCR circuit, the Q factor, the resonance. So with this particular chapter will be over. As far as the NEET is concerned, in this particular chapter you can expect one question which will be a very easier one. You will get to know when I will be doing the numerical problem session. So learn everything to the core, point by point, because there are very few formulas and the formulas are even written in a same pattern for all the things. So this is a very important chapter as far as the exam perspective is concerned. So with this note, I think I will be ending this session. We will again meet in the next session. Thank you.